speed and tell us how big those particles are. And this is an instrument called a nanosize LM20 that does that. And I think we're going to try a video here. If it doesn't come up right away, we'll just move on. Maybe my computer's frozen. Okay, we're not going to look at the video, assuming my computer's not frozen. But it shows what atoms, what polystyrene atoms, so atoms, molecules, nanoparticles look like moving. And they're just kind of bouncing all over. Sort of, okay. You can think about what kids look like when they're out running around, just bouncing all over the place, constantly moving. And that's exactly what particles look like in Brownian motion. Another example of thinking about particles is ferrofluid in Brownian motion. Now, if you've been to some of the exhibits in the exhibit hall, the technology age, there's a giant tub of this stuff. It's called ferrofluid. It looks like a magnetic liquid, but that's impossible. You can't have a magnetic liquid. What it actually is super, super, super tiny nanoscale particles, nanoscale chunks of magnetite, of magnets. Those magnets, those super tiny magnets, are coated in oil, which makes them slippery and makes them behave in really cool ways. When you hold a magnet underneath ferrofluid, it gets those spikes that we just saw and behaves really incredibly. So these extremely small particles are moving around with Brownian motion. So they're constantly moving. And we're going to try the document camera again so you can see ferrofluid. All right. So I have a tube here that has ferrofluid in it. There's liquid, you don't know what kind, and then ferrofluid in there. And I have a really strong magnet that I'm going to keep away from my computer. And you can see that I can drag the liquid around and that there are spikes based upon what I'm doing. And if you want to come see this material afterwards, you can. I have a number of vials that we can share and pass out. So the particles in ferrofluid also behave according to Brownian motion. Another example of nanotechnology of yesterday and today, not necessarily linked to Einstein, is nanogold and nanosilver. Sorry. Nanogold and nanosilver, yesterday and today. So thinking about nanogold and nanosilver, so extremely small nanoscale pieces of gold and silver, they've been around for a long time. One of the ways that they were used unknowingly was in the medieval age, when artisans were creating stained glass windows for churches and other buildings. So this image over here, a stained glass window from a church. The colors in that window are not because of pigment or dye. The colors are actually because of extremely small pieces of copper or silver or gold, and how those behaviors and colors change when those metals get on a small scale. So I talked earlier about how color changes can be one of the things that change. And we talked about gold and silver, or we talked about gold. It happens with silver too. So silver, as we know it in our world, gray, shiny, metallic. But when you get on the nanoscale, silver can look yellow, or blue, or green. We talked about gold earlier and that it changes from being yellow and shiny metallic to being blue or red, depending on the size scale. So this is what gave those medieval church windows the colors. And you can change the size of the pieces of gold or silver to change the color. So if you have 25 nanometer pieces of gold, the color will be red. If you have 50 nanometers and just a little tiny bit bigger, the color will be green. So if you make different size pieces, you get different size or different colors. Same thing with silver. If you have 40 nanometer pieces, the color will look blue. If you have 100 nanometer pieces, the color will be yellow. So changing the size changes the color. So that's how nanogold and nanosilver were used hundreds of years ago. They didn't know they were doing nanotechnology, but they were. Now we know that we're using nanopieces of gold, and we're doing some very exciting things with it. So nanogold today, a primary researcher in this is a woman named Naomi Hollis. She's at Rice University in Texas, and she One of the ways that it's used is in fighting cancer. Naomi, or Professor Hollis, has conducted a significant amount of research using nanogold for cancer treatment. The way that it works is she has these shells that are made out of nanogold, or gold. These shells are only 60 to 100 nanometers across, extremely small. In the middle is just a glass bead or something. By taking those nanoshells to the site of a tumor, using infrared light to heat it up, you kill the tumor without hurting the rest of the body. To sort of lead you through the steps of that, here's a schematic. This is a bag of the kinds of materials that Naomi Hollis's company now produces. So this is a bag of nanogold. It's in a solution, so all of this kind of stuff is in that bag. You get that in an IV, it drips into your body, and then the gold goes to the site of the tumor. There's something specific about the cells in a tumor that cause it to absorb the nanogold shell. You apply infrared light or laser kind of to that area, to the site of the tumor. That causes the gold to heat up, which then kills the tumor. It kills the cells. Your body then reabsorbs the tumor and reabsorbs those dead cells, and the tumor is gone. You didn't have to go through chemotherapy, and you didn't have to make your entire body sick. If you've ever known anyone who's been through cancer, either surviving or not surviving, you know that the treatment is almost as bad as the disease itself. Nanotechnology and these gold nanocells are one way that we're hoping that maybe we can avoid that. Rather than treating the entire body for something that's in a specific spot, maybe we can just treat that spot. And actually, this research is going quite well. It's currently in clinical trials, which means they're trying it out with real live patients. It's not just in the lab anymore. So there's hope that maybe in the near future, people will be able to receive nanogold treatment for their tumors. So silver is another example. These are ways that we have used silver in the past. If you notice, there's something in common with all of them. We have a plate, a pitcher, spoons, silverware. All of them have to do with eating. And when you eat, you usually want to keep things clean. You don't want to be eating a lot of germs and viruses and things. And they didn't really know what was happening, but actually we don't totally know either. But silver is actually an antimicrobial. It kills bacteria, it kills viruses, and so one of the reasons why we've been using it in food items for so long is because it helps you kill germs. So today, we're still taking advantage of the fact that silver kills germs, but we're shrinking the silver so that we can use it in a lot of places where we might not have used it before, not have everything look silver. All of these products look silver. Some of the ones that I'll be talking about don't look silver anymore. So on the top here is a microscope image of nanoparticles of silver that are approximately 15 nanometers in diameter. Extremely, extremely small. So those dots are extremely small. Down here, which looks like juice, that's actually vials of a liquid with silver in them. All of these are silver. I talked earlier about how changing the particle size changes the color, and this is an example of that. The particle is gradually getting bigger as you go to the right, so the color changes. Some of the places where we're using silver in today's applications, we're using nanosilver, are athletic clothes. I mentioned earlier that t-shirts for sporting events often have silver woven into the fabric, so you don't look like you're wearing armor. And then the shirt won't smell as bad after practice. Washing machines, there are some washing machines that have the inside, the drum on the inside are coated with nanosilver, which then helps to clean your clothes extra. Refrigerators, too, have plastic in there. There's also food storage containers. These were some from a company, the plastic